Hi there, my name is Halay. In this third episode of the series, we're going to be doing a couple of experiments that prove that what I've been saying about binaural mics is correct, and that working with them is actually worth the extra effort. So let's just jump right into it. The first experiment is really just to verify that the mics use time delay to create the spatial effect we're looking for, not just a difference in volume. In this experiment, I'm going to snap my fingers to the left of the ears, exactly 70 centimeters away from the left ear and 88 centimeters away from the right. You should be able to very clearly hear that I'm to the left of the microphones. Now, let's estimate what the difference should be in the time it takes for the sound of the snap to reach each ear. Since the temperature in my house is a balmy 24 degrees Celsius and the air is reasonably dry, I can assume the speed of sound is about 345.48 meters per second, or 34,548 centimeters per second. We can calculate the estimated time difference by subtracting the time to the left ear from that of the right. According to these numbers, the sound should reach the left ear about 0.005 seconds before reaching the right. Of course, we're not too worried about the actual value of the time delay, only that it's predictable, measurable, and, well, there at all. Throwing the audio file in Reaper, if we zoom in far enough, we can definitely tell that the sound reaches the left channel before the right. And what do you know, it's almost exactly 0.005 seconds too. Would you look at that? So what does this prove? Well, not a whole lot to be honest, pretty much just that the speed of sound exists, but it's helpful for us to understand what's going on here and for us to see it in action. But does it really matter? This is where the second test comes in. I want to make sure that the sense of directionality you hear from the binaural mics is noticeably better than a normal stereo microphone. The stereo microphone I'm going to be testing against is the classic Blue Yeti USB microphone. I chose this because it's within the same price range as the other mics, also because I already owned it and had it lying around. On the back, I've placed it in stereo recording mode to get the best results. If you're familiar with the Blue Yeti, you might think that putting it in omnidirectional mode would have been the best option, but really all that does is pick up the sound equally from all around it and place it all in the center of what you hear, completely destroying any sense of directionality that you would have gotten from the stereo mics normally. In theory, if I place these mics as close as I can to one another, the only difference between them should be that the binaural mics are a head's distance apart and within physical ears, while the Blue Yeti's two mics are right next to each other within the unit. Let's see if we can tell the difference. I walked around the two microphones playing some familiar chords on a guitar. Let's listen to what each of the mics recorded. Please keep in mind that I don't actually play guitar. This is literally the only thing I learned how to do for the sake of this video, so please excuse how choppy it is. First, let's hear the Blue Yeti audio. Now, let's hear what the TFB2s picked up. You know, the Blue Yeti sounds a lot better than I thought it would. That being said, even though you can still tell the general direction that the sound is coming from, I think the TFB2s are a lot more specific. They're definitely more sensitive, picking up more ambient room sounds, the creaking of the guitar, and I think the spatial effect is more accurate. It's a close call, however, so let me know what you think in the comments. Anyway, that wraps it up for this episode and the introduction portion of this series. Now that we've covered the basics of what we're dealing with, it's time to move on to some experiments that I don't know the outcome of, so that we can better understand the abilities and limitations of these very special mics. Thanks for watching.